A clock dissolves into silence, its hands suspended mid-air like relics of a forgotten dream. Galaxies turn in the dark, their spirals arrested, as if the universe itself had paused in the act of breathing. The human step echoes across empty corridors, yet the foot never falls, the sound never fades. It is the stillness of a universe caught between moments, a tableau where motion seems real, yet everything remains frozen. To human eyes, time is a river. It carries birth, love and decay downstream, in a current that never returns. Childhood is left behind, memories are pulled into distance, and the present dissolves into the past before it can even be grasped. Yet physics whispers another story. It tells of a cosmos where all moments, the birth of the first stars, the fall of Rome, a hand reaching for another in the quiet of a winter night, are already written into the fabric of spacetime, not as fleeting instants, but as eternal coordinates, unmoving, already there. Einstein called it relativity. In his equations, there is no preferred now, no single dividing line between what is and what will be. Instead, the past, present, and future are laid out together like the pages of a book already bound. What we call time's flow may be no more than the turning of our own awareness from one page to the next. If time is frozen, then what is the thing that moves? For as long as minds have opened to the sky, humanity has sought to measure the invisible passage of time. The earliest civilizations carved its rhythm into stone and shadow. Sundials tracked the rising and falling arc of the sun. Water clocks dripped in silence, transforming flow into sequence, a liquid reminder that the world seemed always to move forward. The turning of the heavens themselves became a great cosmic clock, constellations marching across the night like guardians of inevitability. To the ancients, time was not a mystery. It was an ever-present tide, marked by stars, seasons, and harvests. Centuries later, Isaac Newton sought to tame this tide into the precision of mathematics. In his universe, time was absolute. It ticked uniformly, indifferent to human perception, detached from matter, and flowing with the same certainty everywhere. The laws of mechanics unfolded within this unchanging backdrop, like dancers moving across an eternal stage. For Newton, time was the very canvas of reality, unbroken, independent, and beyond question. But centuries of certainty fractured with the vision of Albert Einstein. In 1905, with the theory of special relativity, he erased the absoluteness of time. No longer could it flow identically for all. A clock in motion ticked differently than one at rest. A traveler moving close to light would return younger than those who remained behind. 10 years later, general relativity extended this upheaval. Gravity itself was the warping of space-time, bending both distance and duration. Time, it seemed, was not a universal stream, but part of a four-dimensional block, past, present, and future, woven together in a single, static whole. The experiments followed, cautious but profound. The Michelson-Morley experiment revealed the absence of an absolute frame, erasing the need for a universal ether in which time might flow. Decades later, atomic clocks flown aboard airplanes confirmed the dilation Einstein predicted. Time itself bent with velocity and gravity. The seeds of a radical idea had been planted. Perhaps time does not flow at all. Perhaps what we call the present is merely our perspective, a moving spotlight across a dimension already complete. The first tremors of shock came not from the equations themselves, but from what they implied. If relativity was true, then time was not a river. It was a landscape, a vast, unmoving terrain where every peak and valley, every birth, every death, every whispered word already existed. This is the block universe, a cosmos where moments are not created and destroyed, but simply are, as permanent as the stars themselves. To human intuition, such a vision is unbearable. Life is felt as becoming, not as being. We speak of the present as if it were uniquely real. The past is gone, the future is yet to come, but relativity denies this privilege. There is no universal now for two observers moving differently through the cosmos. What one calls present, another calls past or future. Simultaneity, once thought self-evident, dissolves into relativity of perspective, Einstein himself wrestled with the consequence. In a letter written upon the death of a friend, he admitted that the separation between past, present, and future is only an illusion, albeit a persistent one. For him, the equations demanded a world where becoming was an illusion of consciousness, not a property of reality. Later, Stephen Hawking would deepen the unease. In his explorations of the early universe, he invoked the idea of imaginary time, a mathematical construct where time behaves like a dimension of space, without beginning or end. If true, the question of what came before the Big Bang dissolves, for there is no before. Time, in this framework, is not born or flowing. It simply exists, in forms our minds struggle to picture. The implications are staggering. If time does not flow, then the freedom we feel in choosing, the memory of what is past, the anticipation of what will come, may all be illusions. Free will becomes a shadow cast by a static universe, memory merely the record of a coordinate already written. In the block universe, nothing truly happens. It only is. Relativity begins with a quiet refusal. Its equations do not whisper of a flowing now. They offer no mechanical hand that pushes moments forward. Instead, they describe relations, intervals between events, geometries of motion, the bending of distances and durations under gravity and speed. In Minkowski's formulation, space and time are joined as a single four-dimensional manifold. An event is a point in this spacetime. A life is a world line, threaded through it. The metric determines separations, not successions. Nothing in the mathematics selects a privileged slice that deserves to be called the present. Hyperplanes of simultaneity, those imagined sheets declaring which events are now, tilt and shear, depending on the observer's motion. Two travelers, passing in the void, carry different maps of now, and relativity blesses them both. The field equations of general relativity continue the indifference. They speak of curvature, sourced by energy and momentum, not of a universal clock. Space-time evolves in the sense that different slices can be chosen and compared, but the theory itself refuses to decree which slicing is real. The flow is not in the laws, it is in the gaze that reads them. Yet the refusal is not emptiness, it is testable structure. Humanity placed clocks where the equations said they should disagree. They did. In 1971, atomic clocks flown eastward and westward around Earth returned home out of step with their stay-at-home twins, their offsets matching both special relativity's velocity dilation and general relativity's gravitational redshift. Far above Earth, the constellation of satellites became a daily confession to Einstein's insights. GPS would fail within minutes if its onboard clocks were not pre-adjusted and continuously corrected for relativistic effects. Orbiting high in a weaker gravitational field, the satellite clocks tick faster by roughly tens of microseconds per day, while their swift motion makes them tick slower by a smaller amount. The net drift, if uncorrected, would misplace continents by kilometers. Each successful navigation is a quiet vindication. Time is not absolute. It bends with motion and mass. Particle physics amplifies the message, with particles whose lives are brief and revealing. Muons, born in the upper atmosphere by cosmic ray collisions, should decay before they can kiss the ground. They do not, because to them, time is stretched. In storage rings and colliders, lifetimes lengthen by factors of 10, 100, 1,000, precisely as equations demand when speed presses against light's limit. The same mathematics that denies a single present grants a longer existence to a particle in flight. Time is not one thing, it is many. Braided with motion and gravity, beyond relativity, lies a different frontier, where the language of probability replaces the language of geometry. In ordinary quantum mechanics, time is curious. It enters as a parameter, not as an observable. Positions, momenta, spins. These bloom as operators, acting on states. Time, by contrast, is the stage direction written in the margin. The wave function obeys the Schrödinger equation, which is symmetric under reversal if interactions permit. Nothing in that equation demands a preferred direction, yet the quantum world, so seemingly reversible in principle, owes its practical irreversibility to a phenomenon with soft edges and sharp consequences. decoherence. When a quantum system entangles with countless degrees of freedom, the environment phases smear. Alternatives separate into non-interfering branches, and records form. The past becomes the sum of stable records. The future remains a fan of possibilities that have not yet decohered into particular histories. Still, in the bare mathematics, the evolution remains unitary and time reversal tolerant. The arrow, again, is not in the pristine law, but in the conditions under which it is read. This tension sharpens at the junction of gravity and quanta. Attempts to write a wave equation for the entire universe, the Wheeler-DeWitt equation, famously arrive without an explicit time variable at all. In that frozen formalism, the state of the universe simply is. Change must be reconstructed relationally as correlations between subsystems that serve one another as clocks. Some proposals suggest that time emerges from entanglements bookkeeping. Subsystems play the role of hands that move only relative to other hands. Others, like the Page-Wouters mechanism, try to derive a sense of flow from internal correlations within a timeless whole. The details are debated. The mood is instructive. Where geometry and probability meet, time's centrality retreats, and what is experienced as passage begins to look like an arrangement of correlations on a changeless canvas. If fundamental equations hesitate to anoint a direction, the everyday world does not. Eggs shatter. They do not unshatter. Smoke disperses. It does not reassemble in the grate. The thermodynamic arrow of time, anchored in the second law, declares that entropy tends to increase for systems left to themselves. Boltzmann captured the tendency with a single clarity. Entropy measures how many microscopic arrangements underlie a macroscopic description. A drop of ink, initially confined, can spread into myriad configurations. The reverse itinerary requires an astronomically precise conspiracy among molecules. The equations of mechanics do not forbid such conspiracies. They judge them fantastically improbable. Critics long ago pressed paradoxes against this account. Loschmidt pointing out that time-reversed microdynamics are also lawful. Poincaré demonstrating that bounded systems can recur arbitrarily close to their initial states given enough time. The answers point not to new laws, but to initial conditions. The universe appears to have begun in a state of extraordinarily low entropy. From that special beginning, the ascent to disorder becomes likely. Records form in one temporal direction, and memory becomes asymmetrical. Traces of the past are abundant. Traces of the future are absent. Information theory binds itself to this climb. Landauer's principle quantifies the cost of erasing a bit. To forget is to warm the world. Measurement devices, brains, and biospheres are all machines that create records by shunting entropy elsewhere. Cosmology reaches further back, pressing a thumb upon the scale of beginnings. The cosmic microwave background is the afterglow of a universe that cooled enough for electrons and protons to settle into neutral atoms. At that moment, about 380,000 years after the Big Bang, photons which had been repeatedly scattered could finally travel long distances without incessant collisions. Those photons stream still, stretched by cosmic expansion into microwaves bathing all of space at about 2.7 Kelvin. When radio telescopes receive them, they are receiving ancient light, an electromagnetic fossil that has crossed a desert of billions of years to arrive. It is tempting to describe the background as a picture of then, but in the block view, it is also a statement about there, a spherical surface of last scattering, centered on each observer, where world lines of photons intersect the present location now. Tiny temperature, anisotropies, variations at the level of 1 part in 100,000, encode the seeds of structure that gravity later amplified into galaxies and clusters. Satellites such as SOE, WMAP, and Planck have mapped this sky-filling relic with exquisite precision, confirming a universe that expanded from a hot, dense beginning and fixing parameters that define its history. From the perspective of a flowing time, the background is a message from the deep past. From the perspective of a static spacetime, it is a set of light-like trajectories engraved into the manifold, meeting a world line at a particular coordinate. Both descriptions are true within their frames. Both insist that ancient events are not destroyed by their distance. They subsist as relations waiting to be read. The deeper the investigation, the stranger the balance becomes. Relativity replaces flow with geometry and confirms it in airborne clocks. satellites, and particles outracing their lifetimes. Quantum theory removes the arrow from law, then recovers the semblance of direction from entanglement and the formation of records. Thermodynamics supplies the only robust arrow in sight, tracing its route to improbable beginnings that turn the age of the universe into a theater where order yields to the statistics of disorder. Cosmology preserves a literal illumination of those beginnings, a shell of surviving light that still arrives, still informs, still fits a narrative in which the future is not yet written, while the equations themselves remain silent on writing and silent on flow. The investigation loops back to the central tension. If the laws do not carve a privileged present into the manifold, the present must be a perspectival construct. If microdynamics do not insist on a direction, the arrow must arise from boundary conditions and coarse-grained descriptions. If ancient light can be as present as a nearby lamp in the language of world lines, then presence becomes geometry, not becoming. The heart of the mystery beats in the gap between description and experience. Physics draws a map that contains no moving dot, labeled now. Human life inhabits a story that unfurls one scene at a time. In that gap, further questions gather. Is time fundamental, a coordinate stitched into the essence of the manifold, or emergent, a macroscopic summary of correlations and entropy gradients? Do quantum gravity's timeless equations force a reimagining of change as a relation among subsystems, each serving as a clock for the other? Does consciousness bind these correlations into a felt sequence, or merely read a sequence already implicit in records and dynamics? The instruments keep watch. Atomic clocks become more exact, linking mountaintops with fibers and measuring gravitational redshifts across inches of elevation. Detectors catch gravitational waves, registering the tremors of merged black holes and neutron stars, the geometry itself ringing like a bell. Telescopes, ground and spaceborne, peel back layers of distance to inspect galaxies when the universe was young, testing models of expansion and the statistics of structure formation set into motion by those ancient anisotropies. Each device refines the map, none paints a river. The deeper investigation does not extinguish the paradox. It sharpens it. The laws of nature remain spare and reversible. The universe delivered conditions that lifted an arrow out of symmetry and gave memory its direction. Ancient light arrived precisely as predicted, and yet forever feels like a message from what is gone. If time does not flow but observers do, if a world line is a path through a static hole, then every measurement is a meeting, every record a crossing, every sensation a coordinate. The science is precise, the experience is inexhaustible, and between them lies the question that will not release its hold. What exactly moves? The deeper science peers into time, the more unsettling the silence becomes. For in all the equations of physics, no law defines the present. There is no mathematical variable for now, no universal marker that distinguishes the living moment from what lies before or after. Relativity treats all events as coordinates on a manifold, indifferent to their sequence, to the equations. Caesar crossing the Rubicon and the death of the last star in a cold, expanding cosmos coexist as equally valid entries in spacetime's ledger. The present, so vivid in experience, dissolves into a perspectival slice, different for every observer, with no privileged claim to reality. Yet the paradox runs deeper. Human perception insists that the past is solid, the future undefined. We remember what has been. We anticipate what may come. Records, fossils, scars, and memories seem to confirm that time's arrow points one way only. But physics offers no such certainty. The fundamental equations from Newtonian mechanics to quantum field theory are largely time reversal symmetric. Run the tape backward, and the laws remain valid. The asymmetry we feel belongs not to the equations, but to the improbable boundary condition of a low entropy beginning. Why the universe started in such unlikely order remains one of the most profound riddles in cosmology. At the edges of gravity, the enigma sharpens to a blade. Around black holes, time itself fractures into contradictory perspectives. To an observer falling inward, moments pass normally, their heartbeats steady as they descend. Yet to an outside witness, the infaller slows, suspended on the brink of the event horizon, frozen in time, never quite crossing. Both experiences are correct, reconciled by the geometry of spacetime. Near singularities, the fabric of time is warped beyond recognition, hinting that the very concept may break down where gravity crushes all. The expanding universe adds another layer of disquiet. Galaxies recede from one another, their light stretched to red by the swelling of space, to an inhabitant within time's flow. This is history unfolding. A cosmos aging, stars burning, structures forming and dissolving. But from the block universe perspective, all trajectories already lie inscribed in spacetime. Every galaxy's flight, from birth to dissolution, is fixed, like threads already woven into a cosmic tapestry. The drama of expansion is less a river in motion than a pattern permanently etched into the fabric of being. Here the greatest escalation emerges. Perhaps time itself is not fundamental at all. In certain approaches to quantum gravity, such as the Wheeler-DeWitt equation, time vanishes entirely. The universe is described as a frozen wave function. With no external clock to mark progression, change appears only relationally, one system serving as a measure against another. Correlations replacing flow. Some theorists argue that time is emergent, arising from entanglement, entropy, or coarse-grained perspectives. Others suggest it is born from the holographic structure of spacetime, a shadow cast by deeper laws still unseen. Thus the mystery deepens. If the present is undefined, if the arrow is circumstantial, if black holes and cosmic expansion reveal contradictions in perspective, and if quantum gravity erases time altogether, then the most basic truth of human existence, that we live in time, may be only a useful illusion. What remains is a haunting possibility. The universe is eternal, changeless, complete, and what we call time is nothing more than the shifting angle from which consciousness reads the script already written. The mystery of time has drawn physicists and philosophers into a labyrinth of competing visions, each attempting to reconcile the silence of the equations with the undeniable pulse of human experience. The most austere is the block universe, or eternalism. Here, time is treated as a fourth dimension, no different in principle from the three dimensions of space. Every moment, the birth of a child, the collapse of a star, the last flicker of light in a dying galaxy, exists simultaneously in space-time. Human beings are travelers along world lines, moving through coordinates that are already inscribed. Past, present, and future coexist, as real as one another. In this view, becoming is illusion. The universe is a completed sculpture, not an unfolding performance. Against this stands presentism, the intuition that only the present is real. The past has dissolved. The future has not yet come into existence. This is the lived reality of human minds. Yet physics resists it. Relativity shows that simultaneity is relative. Two observers in motion can disagree on which events are happening now, and both are correct. The cosmos offers no universal present, only a shifting geometry of perspectives. For many, this incompatibility renders presentism untenable, yet its emotional hold remains strong. Some approaches in quantum gravity propose an even stranger possibility. Loop quantum gravity suggests that space-time is not continuous, but granular, woven from discrete loops of quantum geometry. If this is true, time may not be smooth, but composed of indivisible steps, quanta of duration. Flow, in such a universe, would be an emergent illusion of continuity, like the smooth arc of a film concealing its flickering frames. The arrow of time itself may be nothing more than a thermodynamic mirage. Entropy, the measure of disorder, increases as systems evolve toward more probable states. This ascent gives rise to memory, aging, and irreversibility. Yet the laws of physics are symmetric under time reversal. If entropy were to decrease, the equations would not object, only our intuition would. Some argue that the arrow of time is not fundamental, but born from the improbable low entropy beginning of the cosmos. Without that special initial condition, there may have been no distinction between past and future at all. Still others look beyond a single universe. Multiverse models suggest that every possible history exists as a parallel reality. each frozen in its own block of space-time. In such a picture, choices are not made but branched. Every alternative is realized somewhere. The arrow of time may differ across these universes, or vanish entirely, replaced by a kaleidoscope of eternal structures. And then there is consciousness. Some theorists propose that time itself may emerge not from physics but from perception. The brain may stitch moments into sequence, creating the impression of flow where none exists. Neuroscience reveals that perception is delayed by fractions of a second. Memories continuously updated, experience smoothed into continuity. Perhaps time is not the stage on which life unfolds, but the story the mind tells itself to make sense of change. None of these speculations resolve the paradox fully. Each offers a shard of possibility, a block where all is eternal, a present that alone is real, a fabric woven from loops, an arrow born from entropy, a cosmos multiplied into many, or a flow conjured by consciousness itself. Together they deepen the enigma. The question lingers like a shadow. If the laws are silent and our minds are deceived, then what truly is time? If time refuses to reveal its essence in philosophy, science turns to instruments, machines of unimaginable delicacy and power, built to interrogate the silence of the cosmos, across deserts, mountaintops, and the cold vacuum of orbit. Humanity has seeded tools that stretch the limits of precision, each one listening for the faintest tremor in the fabric of reality. In the pine forests of Louisiana and the dry plains of Washington, two immense corridors of steel extend for kilometers, meeting at right angles. These are the arms of LIGO, the Laser Interferometer, Gravitational Wave Observatory. Here, light is split and reflected across vast distances, its returning beams compared for distortions, far smaller than the width of a proton. In 2015, those beams quivered with the passing of a ripple in space-time itself, the death cry of two merging black holes a billion light-years away. Gravitational waves, predicted by Einstein a century earlier, were at last heard. Each detection is not only a triumph of relativity, but also a probe of time's malleability, for these ripples stretch and compress the intervals between events, altering how time itself ticks as they pass through. On a smaller scale, time is tested with exquisite clocks, networks of atomic clocks, tuned to the oscillations of electrons within cesium or ytterbium atoms, now measure durations so precise they lose only a second over the lifetime of the universe. In 2010, researchers placed two clocks mere centimeters apart, one slightly higher in Earth's gravitational field than the other. The higher clock ticked faster, confirming once more that time runs differently with altitude, even across the height of a human hand. Global positioning systems rely on this correction daily. Without it, navigators would be lost. With every refinement, these networks search for anomalies, slight deviations that might hint at new physics beyond relativity. Beneath the soil near Geneva, another tool digs deeper still. The Large Hadron Collider hurls protons together at near light speed, tearing them apart to reveal the particles that compose reality. Among its many tasks is the search for violations of time symmetry. If the laws of physics treat the future and the past identically, then particle interactions should reflect that balance. Yet hints of asymmetry have emerged in the behavior of kaons and bemesons, suggesting the universe itself carries a preference for one temporal direction. Physicists probe these anomalies, hoping they may unlock the mystery of why time appears to favor the future we feel. Beyond the Earth, a new eye gazes outward. The James Webb Space Telescope floats in darkness, its golden mirrors gathering light that has traveled across cosmic gulfs. It captures galaxies as they appeared billions of years ago, revealing a universe still in its youth. Yet in another sense, that ancient light exists now. It is present in every photon striking the telescope's detectors. A reminder that past and present are not erased, but entangled in space-time. Webb's images are not windows into what was, but encounters with what still is, unfolding from across the block universe into the present of observation. The future of inquiry pushes further still. Proposals abound. Quantum experiments designed to test whether the arrow of time can be reversed in isolated systems, or whether entanglement itself generates the flow of moments. Simulations of black hole interiors, run on quantum computers, attempt to model the regions where space-time and time itself may collapse into new laws. Gravitational wave observatories in space, such as the planned LISA mission, will listen for the slow rumble of supermassive black hole mergers, offering fresh clues to how time behaves at its most violent edges. Each tool deepens the paradox. The machines confirm Einstein's vision with astonishing fidelity, yet none explain the passage of time. They reveal that moments stretch, compress, and fracture under gravity and speed, that ancient light is present still, that the arrow may tilt under hidden asymmetries. But none answer the question that remains at the heart of all inquiry. Is time a flowing river or a frozen landscape through which we move? The instruments continue their vigil, carving deeper into silence. With each detection, each photon caught, each collision recorded, science advances another step, not toward dissolving the mystery, but toward sharpening it. For in every confirmation lies a reminder. Time obeys no flow in the laws of physics. The flow exists only in us. Imagine a book, immense and unbound, its pages stretching without end. Each chapter is a moment, already written. The birth of a star, the fall of an empire, the laughter of a child beneath autumn leaves. The ink does not fade, the story does not vanish. We are not the authors of this book, but the readers. Turning its pages in order, line by line, what we call the present is simply the paragraph our eyes rest upon. The past remains intact on the pages we have left behind. The future already waits ahead, silent, sealed, and complete. If all moments exist together, then nothing is ever truly lost. The first breath we drew, the last words of those we loved, the triumphs that lifted us, the griefs that broke us, all remain, eternal and untouched, etched into the geometry of space-time. Our joys do not slip into oblivion. Our sorrows do not vanish into nothingness. They endure, like constellations fixed in a night sky that only seems to turn. To live, then, is not to create fleeting sparks in the dark, but to walk through a gallery of eternal light, each step unveiling what was already there. Yet the haunting question remains. If the path is written, do we walk it freely? Is choice a reality, or only the illusion of motion along coordinates already set? To the physicist, the block universe denies becoming. To the mind, every decision feels alive, weighted with consequence. Perhaps free will is not erased but reframed. Not the power to alter the book, but the dignity of experiencing it from within. And so the mystery closes as it began, with a paradox that refuses resolution. If time does not flow, but we do, then eternity was never about living forever. It was about never being erased.